So a week from today, you'll be taking the open-ended. The open-ended is 3 questions. There's 1 question from probability, like the warm-up. There is a question on factoring with a few different factoring types. And then there's a question from our simplifying roots. Remember that? Like when we use the blue sheet to find the 5th root of something. So there's going to be one of those. Obviously, between now and Friday, we're going to review all of those things, okay? But probability is not one of those things we're going to spend time reviewing because we just did it, okay? So let me know if you have questions on this warm-up, but we're just going to kind of go through the answers here, all right? So the first one, probability of math. Anytime that you have a probability like this without the given line, so the line in the middle, so numbers 2 and 5 have the given line, okay? Anytime the given line's not there, your denominator, at least at the start, is going to be the bottom right-hand corner number. So the denominator for 1, 3, 4, 6, 7, and 8 all have a denominator of 1,000. The only one that has a different denominator is 2 and 5. All right, so at least it's going to start off with 1,000. So I'm going to go to math, and I'm going to look at the 9th graders, the 10th graders, the 11th graders, the 12th graders, the total. So 352 out of 1,000. And then I entered that to get the 44 out of 125. Since there's no given line, your denominator should be the big total, the total. Now, for the next one, this one's different because it's saying I want science given that I'm looking at 12th graders. The second group is your focus group. I'm going to pull my numbers from the 12th graders. So the numbers in my fractions can only be 65, 59, 64, 62, or 250. Like I'm only pulling from that row. So in that row, the science is the 62 and the total is the 250. And then I simplified that. Not 9th graders. Well, there's 1,000 people total, and 300 of those 1,000 are 9th graders. So the remaining 700 are not 9th graders. So I'm taking the big population of 1,000 and subtracting the total 9th graders. Another way to do it is add the 10th plus the 11th plus the 12th. So 700 out of 1,000, or that simplifies to 7/10. Probability of 10th grade. I'm looking at the 10th grade math, the 10th grade English, the 10th grade history, the 10th grade science, the 10th grade total is 175. There's no given line, so that's going to be out of 1,000. And then I just reduced it. 11th grade given English. Your focus group is the English people. I'm only pulling from the 47, 26, 19, 59, and 151. My fraction cannot have any other numbers than 47, 26, 19, 59, and 151. It's got to be from that row. No other numbers can go in this fraction. So of those numbers, the 11th grade number was 19. So it's 19 out of 151, which doesn't reduce. Not science. So I'm going to take the total of 1,000 and subtract the science total of 256. Another way to do it would be to add the math plus the English plus the history. And then that's not science. So 744 out of 1,000, or that reduces to 93 out of 125. So when I see the word or, like I do for 7 and 8, I have to ask myself if these two things can happen together. If this survey is taking a survey of people in the school and then what their favorite subject is, are there 9th graders who could pick math as their favorite subject? Yeah. So this is an overlap. So I'm going to take the 9th graders, 300, plus all the math people, 352. And subtract the 9th grade math people. How many people are 9th grade math? What's the overlap number? 115, where they meet, okay? So I'm doing 300 plus 352 minus 115. But if I put a survey on your desk and I said circle your favorite subject, you can't circle history and science. You're circling your favorite subject, one subject. You can only pick one of those. In other words, there's not an overlap here because since they had to submit one response, they couldn't pick history and math or history and science at the same time. There's no overlap here. So I'm just adding the history to the science. There's no minus. These two rows don't intersect like ninth and math do. What do we think? Anybody have questions on those? Okay, so for today's final review, we are going to focus on our very, very first unit. The first one we did after review was called linear programming. It's when we graphed and we shaded lines, okay? So we are going to review that today. Because it was our very first unit, it's not heavy on the final, okay? It's not going to be an open-ended, but you will see some multiple choice because your final's cumulative. I don't want to throw you into taking a final from something that we did in January without reviewing it with you, okay? So we're going to do a pretty quick review, and then I'm going to give you time to practice those concepts. So before we do that, the final review guide itself is missing page numbers, which is annoying, okay? So we're going to add page numbers in. You'll see on the copy that I sent, there are page numbers. I'm really not sure why they didn't go through, but they didn't. So I'm going to pull the packet up. See how in that bottom corner there's a 1? Is there a 1 for you there? Okay, so that one worked. 2, there's a 2 there? Yeah. All right. So this might be the one that didn't go through. So see how there's not a number here? Let's put a 3 at the bottom of it. All right, so we're doing it together so we make sure we have all the same pages. So this one's going to be my 3. And then this one that's like, how do we add, subtract, multiply, divide polynomials? We'll add a 4 there. And then this rational, section 2 rational exponents, we'll add a 5 to this bottom corner. You guys get the idea, right? This one with 15, 16, 17, 18 is going to be a 6. Can you guys keep going from there? You don't need me to keep. All right, so just keep going. And the last page should end up being 20. Some of them are numbered though, so I don't know why some are numbered and not others, but the last page is 28 and 29. Looks like those have numbers on them. I don't know what happened. This way, when I say go to page 10, like we did for the warm-up, it's not confusing on what page 10 is. You're not like looking for it. You've got numbers now. But the back cover is counting as those last pages, right? If you flip it over. Yeah, like that, in my book, they're counting as page numbers. So 27 sounds right. The last blank page would be your 28, 29. So let's just make sure, at least if you go to page 7, does it have this problem on it? We're good there? Okay, all right. So I'm not going to do all of page 7. I'm just picking some random problems that I think like kind of sum up the unit because we learned it already. So I don't need to completely reteach it, hopefully. So this is called a system of inequalities because it's more than one equation or inequality. And when you graph a system of inequalities, you're looking to both graph the line and then have a shaded region. You might remember like we tested 0, 0 and figured out where we shaded. So what I'm going to do here to graph this first line is I'm going to pretend like that greater than is an equal to, and I'm going to graph this equation. All right? When x and y are on different sides of the equation, this is called slope intercept form. And to graph in slope-intercept form, the first thing you do is you plot the y-intercept. The y-intercept is the number in the equation that doesn't have the x, okay? So in this equation, 4x plus 1, the y-intercept is 1. And on the y-axis, which is the up and down axis, I'm going to make a point at 1. And then the second thing that you do is you use the slope to get to your next point. The slope is going to be the number that does have the x with it. And if the slope is not a fraction, you're going to make it 1 by putting it over 1. The top number of your slope is going to be your up or down number, and the bottom number will always be your right number. You're never going to go to the left when you're graphing. It's like when you read a book, you read from left to right. When you graph from left to right. So we're always going to go right. Now, because this slope is 4 and not -4, it's going to be up. But if it was -4, it would be down. So from this point here, I'm going to go up 1, 2, 3, 4, right 1. And that's where my next point's going to land. You can do that again if you want. Up 4, right 1. You don't have to. It only takes 2 points to make a line. But you can. You could go down the other direction too, if you just want to kind of continue that pattern. But it only takes 2 of these. You don't need all of them. Now, before I go to connect it, there are 2 types of lines in this unit. There's the solid line and the dotted line. Because this graph or this inequality right here does not have an equal to, we are going to connect this with a dotted line. So if you did it already and you did a solid, go through and just like erase pieces of your line. So we're taking our rulers and we're connecting it. Now I'm going to hold off on the shading. I just want to get both lines on the paper first. That's fine, yeah. Especially since this is going to be a multiple choice question. So you'll see the lines rather than having to plot them yourself. All right, so the next line that I have to graph is y equals 2. This is a special line, okay? But it is y equals. So if you have a hard time remembering what y equals 2 looks like, because it's y equals, you can stick it in your calculator. Okay, but remember there's horizontal lines and vertical lines. The y equals ones are the horizontal lines, all right? And the vertical lines go up and down. So this is a horizontal So I got to make a point at y equals 2, right? And then I'm going to connect it horizontally. Before I connect it horizontally, you can maybe throw some points next to it to help you with your ruler. But before I go to connect that, I just have to pay attention to solid versus dotted. Now this one has an equal to sign, so this one's going to be solid. All right, and what this is going to do is it's going to create 4 regions of the graph. Only one of those 4 is our solution. So what we're going to do is we're going to test 0, 0. It looks like 0, 0 is like just on this side of the red line. All right, so there's 0, 0. And when we test 0, 0, we take the original inequality and we put 0 in the y spot and 0 in the x spot. All right, so we end up with 0 is greater than 0 plus 1, because 4 times 0 is 0, and 0 is greater than 1. 0 is not greater than 1. This is false. Here's what that means for the red line. The green point is on the false side of the graph, which means everything on this side of the graph is false. And everything on this side of the graph for the red line is true. Sometimes it helps to take your ruler and put it on the line that you're looking for so the blue line doesn't confuse you, right? So I've got the false side and the true side. Sometimes some of you draw X's. I think we all kind of did this a little differently, but I know that my answer is going to be one of these two regions on the left. All right? Now I'm going to do the same thing, but I'm going to do it with this one. There's no x0, so I can only replace one of the variables with 0. 0 is less than 2 is true. So in terms of my blue line, the green point works. So everything on that side of the graph also works, and everything on this side of the graph doesn't work. You want to shade the true region for everything. So my answer is going to be this region down here. The double true. We're going to do one more of those just to kind of refresh your memory on how to do that, all right? So let's look at the next example, example 6. So the first thing I want to do is I'm going to graph each line. So negative 7x plus 3y equals negative 21. This is called standard form. X and y are on different sides of the same side of the equation. When you're graphing in standard form, the first thing you do is find the x-intercept. You find the x-intercept by keeping the x in the equation, but not keeping the y in the equation, right? So I'm looking at this equation without a y entirely. Essentially what we're doing is plugging 0 in for y. We're just not showing, okay? So when I go through and solve this equation for x, I get that x is 3. So on the x-axis, I'm going to make a point at 3. A lot of times, almost every time that a kid screws this one up, it's because they think the x-intercept is negative 7 and the y-intercept is 3. That's not how it works. You have to solve for it. It's not just there for you in the equation like a slope-intercept form is, okay? So I'm solving for it by solving for x. And then I'm going to solve for y by pretending that that x part's not there. And when I divide both sides by 3, I get y equals negative 7. And y is the up and down axis, so I'll make a point at negative 7. It's not just looking at the equation and seeing what's with x and plotting that at x. You have to solve for x and y. Once you solve for them, you connect them. Now we're going to connect them with a dotted line because this inequality is not inclusive. It doesn't have the equal to line. Okay, so if you already connected it, just erase random pieces of it. Or you could even just make a note like this should be dotted. Oops. For the next one, I'm going to graph the line x equals negative 4. Well, x equals negative 4 is not something I can type into my calculator. Y equals negative 4 looks like this. So x equals negative 4 goes the other way, which is up and down. X equals lines are vertical lines. When I think of x equals lines, I think of exclamation point. An exclamation point goes up and down, right? So I think exclamation point. I'm going to make a point at negative 4 on the x, and then just pick some points above it and below it so that I have points to follow to make that straight line. And this is going to be another dotted line. So for this one, it actually looks like we only have 3 regions. There would eventually be 4 if I had more graphs, but I don't have more graphs. So I'm really just looking between the 3 regions I see. There's the left, the middle, and the right. All right, so let's test 0, 0 on those. Here's the 0, 0. So I'm going to take the original inequality, -7 times 0 plus 3 times 0 is less than -21. 0 plus 0. 0 is less than -21. Is 0 less than -21? 0 is bigger than negative numbers, right? So this is false. And so in terms of the red line, this is false. And this is true. What's this? Would this region over here be false or true for the red line? False. It's another false. It's on the same side as this one. So in my head, this is probably the answer, right? So, but let's just check. Let's check the other one as well. All right, so I'm going to plug 0 in here. Is 0 greater than -4? Yeah. So here's the blue line. This is true, and so is this, because they're both on this side. This is false. So my answer would be the true region. There are a lot of pieces in these problems that you have to remember. Like, do you remember the difference between slope-intercept and standard form and how to graph them, because you graph them differently? So there's that part, right? And then there's the shading part where we're testing 0, 0, and then there's the solid versus dotted part. So all of those things you're going to have to do. The other part of this unit is on the next page, page 8, where we had to read through a word problem and set this up. Now remember, this is going to be multiple choice. So you're not going to have to set it up, graph it, find the corner points, test the corner points, answer the question like we did on our midterm. You already did that. This is just going to be setting it up, all right? So first thing we do is we read through the problem. Monica is a college student who wants to make money over the summer. She has 2 part-time jobs. Monica earns $10 an hour as a camp counselor and $11.50 an hour as a clerk at Five Below. Monica can work at most 16 hours per week at Five Below. How long should Monica work at each job if she wants to earn at least $400 each week? So we talked about when we were finding the variables in this situation. It comes from the question part of the problem. How long should Monica work at each job? So the variables would be me answering that question. Monica should work this amount of time at this job and this amount of time at this job. So there's 2 jobs, and we're looking for the time she's working at each of them. So the first one would be her hours at. The second would be her hours at. And I just need to define the 2 jobs, and I'm going to do it in the order they come in the problem. So camp counselor came first and Five Below came second. You could also say, like, how long Monica should work as a camp counselor. How long should Monica work at Five Below? Like, if you want to put the question in the variables, that's fine too. Now, for the constraints, every constraint starts off with this. Because it's not possible for Monica to work negative hours as the camp counselor or negative hours at Five Below. Because we can't have negative answers, we start here. Which means we've got 2 blanks left. To figure out what goes in those 2 blanks, you look through the problem and you're going to pick out the big numbers. The big numbers are going to go at the end of the equation. So it looks like my first big number is 400. That's the biggest number. And the second biggest number is 16. And what I like to do is underneath that, I like to label what they mean. Because that tells me that everything that's going to go in the green equation is going to have a money symbol with it. And everything that goes in the orange equation is going to have something to do with hours. So we've got $10 and $11.50. Both of those are money. So I'm going to take the 10 and the $11.50 and I'm going to put them in the money equation. 10 was camp counselor, which is X. and 1150 was Five Below, which was Y. The only number that I have left, did I use them all? I used the 10, I used the 1150, I used the 16, I don't have any numbers left. So when I don't have any numbers left, I'll either put an X plus Y, just an X, or just a Y. And it's going to depend on the problem. So let's see what that 16 is. It's 16 hours per week at Five Below. It is specific to one of her jobs. And that job is the job that we defined as Y. So I'm not going to put X plus Y. If it was just she can work 16 hours per week, period, then I'd put X plus Y. But since it's specific to Five Below, I've got to just use Y. You okay so far? All right, last thing is our inequality symbols. 400 is at least. You guys went to Six Flags, right? When you go up to the rides, they have those rulers. It's like, you must be at least this tall to ride this ride, right? It's you and the people above you. Like my little 2-year-old toddler's not getting on the roller coaster, right? So at least means this number or greater than or equal to. At least, greater than or equal to. When I find that 16, it says at most, which is the opposite of at least. So if at least is greater than or equal to, at most is less than or equal to. We're looking at, I'd say, 3 multiple choice questions from this unit. How many did we just do together? We're on to something here. All right, so we've got about 20, 30-ish minutes left. We're going to do some practice with this specific unit. So let's go to page 13 and 14. Let's make sure that they're the page 13 and 14 I want them today since we numbered our own pages. Page 13 and 14 should have graphs on them, and then page 14 should have some word problems where you're setting up, yes? All right, so you're just going to spend some time making sure that you can do these things because they're on your final. What I want to remind you is that your final is 20% of your overall grade. It is going to affect your grade. 20% is 1/5 of your grade. It's a lot, okay? So just in case you're wondering, how is this going to affect my grade? Here's a formula you can use, okay? 0.8 times your current grade plus 0.2 times what you get on your final is going to determine your grade in the course. You can mess around with it. At this point, your grade is what it is. We have no more assignments. You can't do extra credit. I don't do that, okay? So like, if you go in Power School right now and you see that you have an 88, you're going to do 0.8 times 88 plus 0.2 and then guess around. Like, what's going to happen if I fail the final? What's going to happen if I get 100 on the final? You can figure out what your grade's going to be. You don't have to put this grade as a decimal.
Oh.
So the decimals are the ones in front. This is going to be, if your percentage is 78, you're going to put a true 78. Okay, so it just allows you to kind of mess around with your grade. But some of you are going to see, like, if you end up at an 89.2, Gradebook takes you to the 89. It will only round you up if you're at an 89.5. So if you're looking at those decimals and you're going to come to me after the grades are in and go, I got an 89. What do I got to do to get a 90? Nothing. I'm not giving extra credit. What I'm telling you to do is study for your final. Okay, so use this time to make sure you're prepared for that. My suggestion in that would be, let's work on what we did today, and we'll do that each day, and then by the final you'll be prepared, right? The key for this is on Canvas. There's also a video explanation on Canvas if you're doing it at home, but I'm also here right now, so you can ask me those questions too. Got it? You can, if you want to grab your phones and listen to your music while you do that, that's fine with me.